Okay, so we said that for enthalpy, we can't calculate an absolute value for enthalpy. It always has to be relative to something else. It's kind of like potential energy. Although with the potential energy, you may almost think that there is an absolute value for potential energy, because you could say maybe the surface of the Earth. But even that is artificial. It's perhaps convenient, but somewhat arbitrary. So there has to be, for height, for potential energy changes, there has to be a reference point that we measure against. And similarly for internal energy and for enthalpy, there has to be this reference point that we define our changes against. And there's no obvious zero. Now, for entropy S, there is in fact a convenient reference of zero, and that's this zero entropy. And that comes from the fact that as we approach absolute zero, the theoretical lowest temperature possible, we get less and less entropy. If you think about entropy as disorder, it kind of works here. And there's less and less disorder as you get to absolute zero. And a perfect crystal at absolute zero approaches zero entropy. So at absolute zero, with zero entropy, it gives us an absolute reference point that we can compare against. And you can imagine heating up from that and calculate a defined amount of entropy relative to the zero entropy. So this is really a statement of what's actually known as the third law of thermodynamics, and that's the entropy of any perfect crystal approaches zero as temperature approaches zero. 0 Kelvin, which is known as absolute zero. Okay, so if we start with that statement, then it becomes perhaps a little bit more clear that we can now define an absolute value for entropy relative to that well-defined absolute zero point of entropy at absolute zero. And as I said, this statement is known as the third law of thermodynamics. And it has more broad-ranging application than just this. In fact, it helps us to understand why you can't reach absolute zero. But what I wanted to do was just address why, if you look in a table of standard enthalpies and entropies and even Gibbs energy tables, you will notice that there's always going to be these deltas H, I should say actually. You might even see deltas G, but entropy will show without the delta. And the reason is because we can determine an absolute value. I'm having trouble spelling today. There we go. Absolute value for entropy relative to the zero entropy at 0 Kelvin. Okay, thanks a lot.